Happy New Year and welcome back to Clueless FM, the first Clueless FM in 2018. So, when I first made a version of this graph back in September of 2014, we were like about here, and I had a feeling that we would go downwards like this yellow graph and the green graph, but we didn't have the data, so I didn't know it would be this similar to the other graphs. And there was a lot of worry when I published this graph because it doesn't display seasons. It doesn't display more ice in winter and less ice in summer, autumn. And it's because it's designed to do that. It's like this is a 365-day average extent. So every point in the graph consists of the past 365 days, the past year. And so instead of trying to prove that we have winter and that winter is colder than summer, which is obvious to my mind, instead of that, this graph shows you that we have something called climate change and a warming signal. So that's one of the things it proves, and it also makes other things that you didn't know about become apparent. So, for instance, when you have a year that starts with a high annual average, like 2004 here, and ends up lower than it started, that's a sign that you have a steady warming of the Arctic and that ice is going away as a result of that warming, right? So for most of these years, from 2004 to 2017, 11 of those years go down, over the year. And only 3 of the years go up. So that's a pretty clear statistic for a warming signal in the north. And there's a lot of interesting things to get from this plot. For instance, the minority, the 3 years that go up, they are 2008, 2013, and 2017. These are interesting to study. Why do they go up, right? So what you can see is that each of the 3 years that end up climbing in this plot, they follow a very abrupt loss in the previous year. Like here it is 2007, a record low year for volume and extent. And here is 2012, which was also a new record when it came. And what about 2017? Well, we had 2016, which also had a very abrupt loss event for annual extent, and which also went lowest ever for annual extent. 2016 did. So it's interesting to see what these positive feedbacks, these negative feedbacks, these counter trend years are doing. So first you have a climb from the lowest ever for 2007, and in 2008 the annual extent climbed to not lowest ever, and the volume, the annual volume in 2008 went up from the lowest ever in 2007 to the second lowest, and for 2013 volume went up from lowest ever again and to fourth lowest. So the rise in annual extent was followed by a similar rise in annual volume. But how's that in 2017? Because the annual extent climbed, as you see here, and we lost the lowest ever status and went up to the second lowest at the end of 2017. But volume actually gained the lowest ever position. So so following this abrupt drop in 2016, there was a negative feedback with the annual extent sort of reacting to this sharp drop and going up to second lowest. But the volume didn't follow suit. The annual average volume actually went the other way and went down from second lowest in 2016 to the first or record low for 2017 annual volume. So that's maybe a sign that the warming signal is now even stronger. You know, that even if surface two-dimensional ice extent reacts to more fresh water or more melting water in the top layer, perhaps same thing doesn't happen at the depth or 1 or 2 meters down in the water layers, because that's still salty and that's still relatively warm water. So the volume actually goes down over the year 2017 on the annual average plot. So what else can we deduct from this plot? I think it's fair to say that we can expect 2018 annual average extent to continue a downward slope. You see at the end of the 28 rise there was a decline, even if it wasn't very large decline. It was a decline over the year, and the same thing in 2013-14. It's peaking here on January 4th, and it goes down. So we can assume it's going to go down, like, I would say, for at least the next 2 or 3 months. And it generally going down over these months makes it also more likely that the winter peak, the 2018 maximum extent, will likely be lower than even last year, which was the lowest ever. So it's very likely that you will have a new low for the winter peak. but it's this graph can go down generally, even though it's like maybe minor upticks along the way. So, and if there's an uptick around mid-March, then maybe we won't be lowest for the maximum. So another thing that is likely from comparing 2018 to 2009 and 2014 is that overall during the whole year 2018 we will end up lower than we started up here. That's been the pattern thus far. And yeah, another thing is what's that? Yeah, another thing is that what's been called a 5-year cycle in the title of this plot, it seems to have gone down to a 4-year cycle, or maybe just throw away the whole cycle concept, because you start off 2007 here with this type of graph, a sharp decrease, and then it repeats like in 2012 with another sharp decrease in the autumn. But that sort of abrupt loss only takes 4 years to repeat here in 2016, right? So if anything, it seems to, if there would be some kind of repeating pattern, it's speeding up so that the period is shorter. The period would now be like 4 years. But even though it does look like a pattern, it doesn't mean it's a real phenomenon. But the Arctic is changing very fast, and what used to be normal or regular patterns in the past doesn't necessarily continue in the same way. So I think it's interesting that there may be reasons to believe that the stratification or there's been sort of a split now with the annual extent going up and annual volume going down during the same year. It seems to indicate that you have like an increased amount of cold freshwater in the surface, while the warming trend 1 or 2 meters below that is still going on and still melting more ice under the surface, reducing the volume. So I'm sort of expecting sea ice volume to go even lower during 2018, because the thickness and volume is the thing that is actually melting, and it's actually reacting to all the factors in the Arctic, while the surface effect of sea ice area and sea ice extent is more, let's say, flip-floppy, more uncertain, because it's just reacting to the very top layer, and more reacting to the randomness of weather and stuff. So yeah. So as I said, I'm expecting this peaking and this turnaround and going lower to continue into the last weeks and months of winter and into spring. But of course we will return to this in 2 or 3 months and see how we're doing. Okay, thank you for listening. Bye.